Okay, so here's one of those problems where students get like, all right, I understand everything, but I hate math. Why do they have to do something like this? And the reason why we present problems like this to you is to get you thinking, right? It's not just everything doesn't always follow along a perfect path. You always have to understand kind of the basics of something and then see, all right, how can I apply that to a problem that maybe looks a little bit differently? So we can see that our numerator is not in descending order, right? Our denominator is. And we know since we have our two trinomials, I look at them, I do not see by inspection that I have a trinomial that I can factor out anything, factor out any GCF, or do I have any special factoring techniques such as difference of two squares or a perfect square trinomial. So one thing I like to do when I have a negative x squared is I don't really like to factor with negative x squared. You can, but I think it's a lot easier to factor out a negative. So let me use a different marker for this. Let's factor out a negative so it becomes positive. So if I factor out a negative, that means now my negative 12 is negative, or my 12 is now negative, my x is going to be positive, and my x squared is going to be positive. Then what I'm going to do is I'm going to rewrite the problem. So it's going to be rewritten as a negative x squared plus x minus 12 divided by x squared minus 8x plus 15. Okay, so all I simply did was now just rewrote it. So now my numerator is being multiplied by a negative 1, but I rewrote it in descending order because I think when factoring it, it's going to be a little bit easier. So I know to simplify this, I now need to factor my numerator and I need to factor my denominator. And notice now they're both in our form of ax squared plus bx plus c. So let's go back and let's do these separately. So I'll have my numerator and I'll go and factor my denominator. Now remember, when factoring, we always want to take our value of c on top and then our value of b on the bottom. And we're going to say what two numbers multiply to give us c, but then add to give us b. What two numbers multiply to give us c, but then add to give us b. So we take a look at our c, and in this case, my c is going to be a negative 12. Inside the parentheses, we have a negative 12. And my b is going to be a positive 1. That's the coefficient. Over here, I have positive 15 and a negative 8. All right, so now what we're going to do is we need to write out the factors. If you can't already do this in your head, let's write out the factors. So if I have 12, I'm not going to be concerned right now if it's positive or negative. Let's just work on all the factors. So I could do 12 times 1. I could do 6 times 2. I could do 4 times 3. And it seems like that's everything we got. Make sure, though, notice how I just did all the higher numbers, the larger numbers on the left-hand side and the smaller factors on the right-hand side. That's just very helpful, especially when we deal with negatives. I think we're going to do the same thing over here. So we need to figure out what are all the factors of 15. So 15, I could do 15 times 1, or I could do 5 times 3. All right, so let's go back to this. Remember, when we're doing this value, we say, what factors multiply to give us negative 12, but then add to give us 1? Now remember, when we're multiplying to give us a negative number, one of these values, one of these factors has to be negative. But if they're adding to give you a positive number, that means the larger factor has to be positive. So we can just now write a negative number in front of each one of these little factors. So now I say, all right, out of these factors, we all know that multiply to give us negative 12, but which one of these add up to give us positive 1? You can see there's only one set, which is 4 and negative 3. Then we look over here. So I have two values that multiply to give me a positive 15, but they add to give me a negative. Now remember, if two numbers multiply to give you positive, it could be two positive numbers or it could be two negative numbers. But if they add to give you a negative 8, then we know that both the factors have to be negative. So out of these two different sets of factors, which two values add to give me negative 8? Because we know they both add to give me a positive 15. Well, we can see that's going to be negative 5 and negative 3. OK, so now let's rewrite and simplify this out. So therefore, I'll have a negative. My numerator has now been factored to x plus 4 times x minus 3. And my denominator has now been simplified or factored to x minus 5 to x minus 3. All right, and now we can see that we're dividing a binomial over another binomial that are exactly the same. So those are just going to divide out to 1. Now, we could distribute this negative sign, or you can just leave it on the outside. It's not really going to affect our answer, but we'll have a simplified version of a negative x plus 4 divided by x minus 5. Or you could simplify that to a negative x minus 4 divided by x minus 5. But either way, you can't simplify this any further. So there you go, ladies and gentlemen. That is how you simplify by factoring out of -1. Thanks.